Hello, this is Dr. Strickland. In this video, we will begin our investigation of the systematic nomenclature of alkanes. Take a minute to read through these student learning objectives. These are the things that you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. So the names that we've been looking at so far are common names. And so before there were 16 million organic compounds and counting, the person who discovered a compound could name it whatever he wanted. Could name it after your dog or your mom or your hometown or whatever else. That's how we got names like baking soda, rubbing alcohol, and graphite. So there were two options. We could learn 16 million different names, or we could learn a set of nomenclature rules that will create a unique name that describes the structure of any particular organic compound. And these are called the IUPAC rules. And from them, we construct systematic names. This lets people in different countries who speak different languages have exactly the same names that go with the same structures. And so they can talk with each other in a way that people couldn't before, because people in one country might have completely different common names from the people in a different country. So this was a huge thing in scientific progress and allowing people to collaborate. So I love it for a lot of reasons, and I hope you'll like it too, but mostly I want you to be good at it. So let's see what we can do. So we're going to draw the Lewis structures for all of the constitutional isomers having the molecular formula C6H14, beginning with the straight chain, that is unbranched alkane. Okay, so we're going to do this one at a time. And instead of doing Lewis structures, I think we will do condensed structural formulas. So you know that the unbranched one is just 6 carbons in a row with the hydrogens attached to a particular carbon coming just to the right. So you can have 6 of them in a row, and then you're kind of done with a chain of 6. So let's be systematic about this. We could have 5 in a row. And 1 methyl branch, like maybe here. Is there any other place where we could have a methyl branch? Well, we could do it on the middle carbon. So let's set up another one with a 5 carbon chain and put the carbon there. Okay, so those are the only unique positions for 1 methyl branch. So let's put the hydrogens in. All right, so I want you to pause the video, put the hydrogens into both of these structures, and then come on back. All right, welcome back. So 3 on every primary carbon, 2 on every secondary carbon, 1 on this tertiary carbon here. So we're doing the same sort of thing here. It's just that the position of the tertiary carbon has moved. All right, so we've done 6 in a row, 5 in a row. Let's do 4 in a row. 4 in a row with 2 methyl branches. Where could they go? Well, we could do 1 on each of these carbons. Pull this up a little bit. Or we could do 2 on 1 carbon. Like this. And now we've got our first quaternary carbon there. Okay, so let's put the hydrogens in. All right, 4 primary carbons, 2 tertiary carbons. Here we've got 1, 2, 3, 4 primaries, and a secondary, and a quaternary. Okay, and you can check them and make sure they all have the same number of hydrogens. All right, so let's do the skeletal structures. All right, you know that anytime you have a line segment both ends represent carbon atoms with the number of hydrogens assumed so that every carbon has 4 bonds. I say that makes the carbon tetravalent. And we could number this straight across. And the systematic name for just a straight chain alkane is determined by the number of carbons in the chain. Now it's an unbranched chain. It's actually not straight, and it's drawn this way, this zigzaggy way, to remind us that each of these carbons is tetrahedral. And so this is a much better representation of what the structure actually looks like than just a straight chain. All right, so if we're going to do this one, let's do 5 in a row. And then we've got a methyl branch here at that second carbon. 1, 2, 3, 4, 5. Okay, 5 carbon chain is a pentane. And we've got a methyl branch here at carbon 2. So that makes this 2-methyl pentane. All right, so I want you to do the skeletal structure and the name of this third one. So pause the video and do those, and then come on back. And welcome back. So it's pretty closely related, still a 5-carbon chain. The branch is in a different location, and we can confirm that by putting the numbers on the carbons in this main chain. The main chain is called the parent chain. Oh, and so the name is only a little different. This is 3-methyl pentane, because the only thing that's different is the position where the methyl branch is attached. All right, so 4 carbons in a row, that's butane. So we're going to do our 4-carbon chains like this. Now, if you've got a branch attached to a carbon in a skeletal structure, you know that if the intersection is up, then anything else attached to it is also up. And if the intersection is down, anything that's also attached to it is down. If you've got 2 things attached to the same carbon, and that intersection is up, both of them go up. All right, so this is 1, 2, 3, 4 in both cases. Now, when you have more than one branch, each branch has to have its location number or locant, and there has to be a multiplying prefix that tells you how many. So this is 2,3-dimethylbutane. Okay. And you can see that there, unlike common names, there are no spaces between the L of methyl and the B of butane. If you have numbers, they're separated by commas. If you have a number adjacent to a letter, it's separated by a hyphen. And that's true of almost, I can't think of any exceptions to it right now. If we come across an exception, we'll talk about it. All right, so how is the name of this different? It's still a dimethylbutane, but both of these methyls are attached to carbon 2. Each one still gets its own number, so it has to be 2,2-dimethylbutane. All right, so this is the very beginning of this story, and when you're finished, you'll be able to look at, the prescription inserts with those names that are like 3 lines long, and I don't expect you to be able to, come up with those, but it's cool to be able to see that, you can recognize parts of it. So at least I like to do that. Everybody needs a hobby, right? All right, so this is the beginnings of the story of systematic nomenclature. If you have any questions on this, please send them to me.